We have officially reached the end of the Pragmatic REST APIs course, and our dev habit REST API is successfully running in production. If you enjoyed this course and learned something valuable, I would really appreciate it if you could take a moment and leave a testimonial from the form that's going to be right under this video. It's only a couple of steps and it will take you at most 1 minute. I want to thank you for being a student and spending the last few hours with me inside of this course, and I hope that you gain some valuable knowledge. Until the next time we see each other, stay awesome. Welcome to the case study of the Patreon API. Our goal in this case study will be to explore the API surface that's offered by Patreon, and we are going to analyze this and compare it to everything that we learned in this course. So let me walk you through the agenda for this case study. First, I'm going to give you a brief API overview of what the Patreon API offers. We're also going to understand what the business behind Patreon is and how their API complements this. We're going to explore the core resources that the API exposes and what are its capabilities. We're also going to discuss the resource naming and hierarchy approach. Then we're going to look at the request and response formats that the Patreon API uses, and we're going to discuss the key REST principles such as HateOS and if this is supported inside of the Patreon API. But we're also going to explore some other topics like the API versioning approach, the rate limiting policies, and how the Patreon API approaches error handling. And of course, we will have to discuss the authentication mechanism that is used by this API. But first, let's try to understand the business that is Patreon and what it offers. If you've never heard of it, Patreon is a platform that allows creators, such as myself, to share some exclusive content with their audience. Now what you're seeing here is my Patreon page, and I'm not using this as an advertisement, but you're welcome to check it out if you find it interesting. However, what I want to focus on is what the client side looks like, and then we're going to discuss the API and what it actually offers. So first of all, you can see that we have a top-level resource representing my Patreon page, and then we can choose between memberships, so this is another resource, and then we have the content or posts that I'm creating, which represents yet another resource. Now something else you can do is add comments on these posts, and this is another functionality offered by the API. However, I'm just showing you this to demonstrate what Patreon looks like. When we check out the API, you will see that it's actually not meant to power the user interface. This is the documentation for the Patreon API, and this is how we are going to review the API as part of our case study. So right off the bat, you can see the menu that offers some top-level information that might be relevant if you want to integrate with this REST API. The notable sections are clients and API keys, OAuth, errors, rate limits. Then we have some documentation about the version 2 of the API, so you can see that the API is using versioning and is discussing OAuth, resource endpoints, webhook endpoints, and the specific resources offered by the API. Another section for the resources and API endpoints, some details about pagination and sorting, webhook support, integration with external services, and then some frequently asked questions. So what is this API about? It's actually not meant to power the Patreon platform. That API is private. The public API that is exposed here allows you as a developer to integrate with the Patreon platform for one or more Patreon pages, or you could also build an integration for Patreon members. This is similar to how we use the GitHub API to integrate it into our dev habit application and expose some additional functionality on the API and inside of the client application. Now let's explore what we can do with the Patreon API. We're going to follow the outline that we have here and comment on each section separately, and I'm going to try to tie everything into our overall discussion about REST APIs. So one thing I'd like to highlight here is their approach to API change management. They are explicitly communicating that the version 2 of the API is what is being maintained, while the version 1 API is supposed to be deprecated. So you shouldn't be using it, and you should be using the version 2 API. We'll see if they provide more details about migrating from the version 1 API into version 2 endpoints. Let's see what else we have here. You can see that I have some API libraries, which are basically SDKs that allow you to integrate with the Patreon API. But one thing that caught my eye here is that the Patreon API follows the JSON API specification. If we make a quick detour, you might remember the JSON API specification from our discussion about K2S and Hypermedia. This specification documents how you should build APIs in JSON, and it provides a standardized format for how you should represent resources. And we highlighted that this also includes Hypermedia links, and it also comes with its custom media type, which is a vendor-specific media type called application/vnd.api plus JSON. So this is just a brief reminder. I'll leave a link to this in the resources under this video. Now let's go back to the Patreon API. I don't want to spend any time on the specific libraries. What's notable is that there isn't a .NET library unless somebody builds it, but let's see what's next. We have the clients and API key section. Now this explains the authentication mechanism that the Patreon API uses, and you can see right away that they're using OAuth to allow clients to integrate with the Patreon API, where you first have to register your client, and you're going to be issued the client ID, the client secret, the creator's access token, and the creator's refresh token. And you can use these values to authenticate with the Patreon API using the OAuth specification. The next section is specifically about OAuth and how it works in the context of the Patreon API. Now this section here assumes that you want to expose a client application that allows someone to authenticate with Patreon from within an external system that isn't really Patreon. This will require the external system to be a registered client to be able to do this. An alternative is that you could use the creator's access token in place of the access token you would get from the OAuth flow, and you'll be able to authenticate with the Patreon API. Now the flow that they are describing here contains a couple of steps. You have to register your client, you have to expose a login button that's going to redirect to the OAuth 2/authorize endpoint. And this is basically the authorization code flow. You can also see this based on the request that you should be sending that contains a query parameter, which is called response type, and the value is code. Now, if you recall from the authentication and authorization section, we discussed the authorization code flow with proof of key code exchange as a modern approach to implementing OAuth. The Patreon API is using just the regular authorization code flow, which is still considered safe. You also have to provide your client ID, the redirect URI. This is where the Patreon API will redirect a successfully authenticated request. Then you're going to specify the scopes that should be included in the access token. This is an authorization mechanism. And then you can also pass in an optional state value, and this is meant to prevent cross-site request forgery. Now moving on, you'll see the next step, which is how to handle the OAuth redirect after a successful authentication flow. How this works is Patreon is going to send a simple GET request to your redirect URI, but is going to append two query parameters. One is going to be the code value that you can exchange for an access token, and the state value that you can compare to the one that you sent in the original request, and this allows you to introduce additional validation. Then in the next step, you will use the code that you got in step 3 to send a request to the OAuth 2 token endpoint, and you're going to specify the single-use code. The grant type will be authorization code, and you have to provide the client ID and the client secret. Now note how this is supposed to be used. Because you have to provide the client secret, and this is a value that shouldn't be publicly exposed, you really want to be doing this inside of the server. After successfully obtaining the access token, you'll get a JSON response in this format. And finally, after you get back the access token, you can use it to call the available API endpoints. I'm going to skip over the steps 5 and 6 because they aren't as interesting. And in step 7, there's a description of how you can refresh the access token. You call the OAuth 2/token endpoint, and you specify a different grant type. This time it's called refresh token, and this is pretty standard for an OAuth 2 flow. It basically works the same regardless of which OAuth provider you are integrating with. You provide the refresh token that you got from the authorization code request, and you provide the client ID and the client secret, and you will get back a new access token and a refresh token. Remember that this is something that we also implemented in a less secure way, where we exchanged a username and password for an access token and refresh token pair, and we just allow our clients to pass in a refresh token to obtain a new access token and refresh token pair. This approach is a little bit more secure, which is also why the OAuth specification is an industry standard when it comes to implementing authentication and authorization support. Moving on, we get to the documentation about the API errors, and this mainly documents the HTTP status codes that are used in error responses. This should help us understand what we could expect from the API. So you will see some very standard responses like 400 bad request, 401 unauthorized, 403 forbidden, 404 not found, 405 method not allowed, 406 not acceptable when we don't specify the supported media types, 410 gone. This is interesting, and we discussed whether we should be using this or 404 not found to represent that some resource is missing. Then we have 429 too many requests, and of course the server errors, 500 internal server error, and 503 service unavailable. So just quick documentation of what you should expect in terms of HTTP status codes for error responses. Then we have documentation about the rate limits, and you can see that we are allowed to make 100 requests in 2 seconds, so pretty generous, and this is on the level of a client across all access tokens, but we also have another rate limit based on the access token that permits 100 requests per minute. If we exceed the rate limit, we're going to get back a 429 too many requests response, and this is what the response is going to look like. We're going to get a JSON object with errors at the top level. It's going to contain the code name, details about the error, the identifier that is assigned to the error, when we should retry sending a request, the status code, and the title with some additional details. So you can see that this isn't quite the problem detail standard, which I recommended that you should use for reporting API errors, but another thing that's important is keeping your error responses consistent. So as long as we can expect a uniform error response, regardless of the HTTP status code, then we should be able to systemize how we handle errors from the Patreon API. Now moving on with the documentation, and I'll try to pick up the pace because we don't want to do a deep dive on all of the functionality. We're mainly interested in the design choices that they are making and comparing them to what we discussed in the Pragmatic REST APIs course. The next section relates to the version 2 of the Patreon API, and it's titled OAuth. Now this section highlights the differences between the version 2 and the version 1 APIs. It discusses some changes in the resources. It introduces a potentially breaking change to the API surface, which says that all data attributes and relationships must be explicitly requested with the fields and the include query parameters. So this is actually data shaping and something that we discussed in this course, and I showed you how to implement this from scratch. Now the Patreon API additionally supports resource expansion. I only mentioned this briefly, and they use the include query parameter to support this. They use scopes that you specify when obtaining the access token for authorization purposes, and they also have support for webhooks. The next section describes the scopes. We're not going to look at each one in particular. What matters is that having a specific scope will allow you to execute the appropriate actions on the Patreon API. It's kind of similar to the roles-based approach that we implemented in the DevHabit application, except the scopes that are specified here determine your rights to particular resources exposed by the Patreon API. Now, another thing that is interesting is that the user who is going through the authentication flow has to explicitly permit the use of these scopes. So the user also has a say in which scopes will be allowed when going through the OAuth flow. This should also illustrate why OAuth is mainly a specification that deals with authorization and what you are allowed to access on the API. Now moving on, we can see the comparison to the old scopes. Now what's interesting is the resource endpoints. Let's see what they are exposing and what are some standards that they are using for their API. First, they're using a fixed host name where we should be sending all of the requests. And then we have a couple of API endpoints. There's a GET endpoint with a route prefix of API and OAuth 2, and then version 2. So you can see that they are using URL versioning for their API. And then the resource is identity, and this basically represents the currently authenticated user. We modeled this in the users/me endpoint inside of the DevHabit application. You can see some detailed documentation about this endpoint, for example, which scopes are required to get back certain pieces of information, how to do data shaping on nested resources, or you can alternatively do resource expansion. Now let's take a look at a potential response and what it might look like. You can see that they have a top-level data property that contains the information about the current resource. They're also documenting the resource type, the attributes for the resource identifier, and then there are the relationships for the resource. And what do we see here? We see hypermedia links. So this will give you the related campaign to the current resource, which is the user in this case. If we have any included properties, they're going to be in the included array, and this represents the data from related resources, in this case the campaign represented by the type here. And then there's also the self-referencing hypermedia link, which points to the current resource. So right away, you can see that this API follows some of the conventions that we discussed. Mainly, it uses hypermedia, but the resource representation is not application JSON. This is the JSON API media type. And with this media type, this is how you represent your resources. Now, if you go through the remaining endpoints, we will see more of the same. You can see that the route prefix remains consistent. Then we have a new resource called campaigns. The representation of this resource, we can fetch a single campaign by appending the campaign ID, and we'll get that resource back. The next endpoint